Ramanujan for G is now available on the Google Play Store. Try it out for free.
Hello everyone. So here in the metrics we'll see some special cases today. Okay. So there are total 11 okay special cases for the metrics. Okay, so one by one we'll see, then we'll solve some example based on this. So first is our orthogonal matrix. So here a square matrix A is called orthogonal matrix. So A of A transpose is equals to I. So you can write it as A transpose A. So which becomes A inverse is equals to A transpose, which becomes A inverse is equals to A transpose. So for example, suppose matrix is given 1 0 0 0 1 0 and 0 0 1, right? So here we can write A inverse is equals to A transpose, right? So here this when you going to find the transpose of this is equals to A inverse also. So this property you need to remember. Okay, so this is our orthogonal matrix. Now the second is idempotent matrix. So here A square is equals to A. So given A square is equals to 8, let me highlight this. Okay, A square is equals to A, right? So let's look at example half, 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 half. Okay, so this is our idempotent matrix. So here we can write, when you're going to square this matrix, you will get it as same. Okay, so this is our A square is equals to A. Okay, so first orthogonal, second idempotent matrix. So two special cases we have seen. So first copy these two, then we'll see the third one, which is involutory matrix, right? First, A inverse is equals to A transpose. That can say A square is equals to A. So these are two special cases. Now the third one is A square is equals to I, or A inverse is equals to A. Okay, example is given. A of matrix 1 0 0 0 1 0 and 0 0 1, which is a involutory matrix. Because when you're going to inverse, you'll get same, or you're going to A square, you will get it as I matrix. Okay, so let me discuss the fourth one also, which is a nilopotent matrix. So a square matrix A is called nilopotent matrix if there exists P belongs to N such that A to the power P is equals 0. So suppose a matrix is given 0 0 0 and 2, which is a nilopotent matrix, right? So first copy down these four. Okay, then we'll see more special cases. Next, fifth one, the conjugate of a matrix. So the conjugate of a matrix is a matrix which whose each element is the conjugate complex number or corresponding element of the matrix A. Meaning, conjugate transpose matrix of A is transpose a matrix of conjugate of matrix A, and it's denoted by A star or the A naught. Okay, so A star is equals to A bar of transpose. So this you need to remember. Okay. Next is Hamilton matrix. So which is a theta, a power theta is equals to a, that is aij, which is equals to a bar ji. Okay, let me highlight this here. A theta is equals to a, that is aij is equals to a bar ji. Okay, which is belongs to ij. So this is a Hamilton matrix. Next is skew Hermitron, Hamilton. So you can write it as this a is equals to minus of a power theta, okay, which you can write it as aij, which is equals minus of a bar ij. Okay, now next is period of a matrix. So if for any matrix a k plus 1 is equals to a, then we can write it as k is called a period of matrix where k is a least positive integer. So give an example, a cube is equals to a 5 is equals to a 7 is equals to a. Then it's period matrix, then it's a periodic matrix, and a to the power 2 plus 1 is also equals to a. So this is of period 2. Okay, meaning n plus 1, so n is here the period, or k, we're written as k. Always remember k is a least positive integer. Next is differentiation of a matrix. So if fx, gx, hx, and lx, then we need to differentiate the given matrix. So dA by dx, which become f dash x, g dash x, h dash x, and l dash x. So which is differentiation of matrix. So suppose a matrix is given x square sine x, 2x, and 2. So we need to differentiate this dA by dx. So differentiation of x square, which is 2x, then differentiation of sine x, which is cos x, then differentiation of 2x, which is 2, and differentiation of 2 is 0. So our matrix is become 2x, cos x, 2, and 0. Okay, so this is for our differentiation of a matrix. Okay, so till ninth we are covered. Two more are there. Okay, so next is the submatrix. So let A be M into N matrix. So then a matrix obtained by list leaving some rows or column or both of A is called a submatrix of A. So given A dash is 210, 322, and 253. Okay, and the second is 2253. So submatrices of matrix A will become 210 and 2 minus 1, then 3224, then 2531. Okay, so this is your submatrices of matrix A, because they have just pull out this matrix. Okay, 2 into 2 matrix, right? And this was in 3 into 3. So let me write it here, 2 into 2, and this is 3 into 3. Okay, and here they made 3 into 4. Okay, next is 11th rank of a matrix. This is important. Okay, so in the first year of engineering also you're gonna learn this rank of a matrix. Okay, so here a number I say to be a rank of a matrix, I mean to n matrix A, if conditions are given. First, every square submatrix of order r plus 1 or more is singular, right? The second is there exists at least one square submatrix of order r which is non-singular. Okay, So rank of matrix is the order of the highest order non-singular submatrix. So let's see one example. So we need to find the rank of a given matrix, which is 1, 2, 3, 4, 5, 6, and 3, 4, 5. Okay, so here we have modulus A is equals to 0. So rank of A is less than 3. Okay, so we observed 5, 6, 4, 5 is a non-singular square submatrix of order 2, right? 5, 6, 5, 4, 5. So here a rank of a matrix will become 2 because it's of a 2 into 2 matrix, right? So I hope with this example you got. Now there are three cases the note is given. First, the rank of the null matrix is not defined. Okay, is not defined, and the rank of every non-null matrix is greater than or equals to the one. Okay. Now the second is the rank of matrix is same as the rank of its transpose. That is, rank of A is equals to rank of A transpose. Okay. Next is elementary transformation do not alter the rank of matrix, right? So these three notes you need to remember. The first is rank of matrix is not defined, and rank of every non-null matrix is greater than or equals to 1. Second is rank of A is equals to rank of A transpose. Okay. And third is elementary transformation do not alter the rank of the matrix. Okay. So you can copy down these three notes as well as the rank of matrix. Okay. Next is given example. So if A is 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay, this given matrix we need to find adjoint of adjoint A equals. Okay, so here we know adjoint A is modulus A n minus 2 into A. So now if n is equals to 3, then adjoint of adjoint A will become A of modulus A of A, right? So here we can write it as 1, 2, 3, 3, 2, 1, and 3, 1, 2, as A is equals to 1 into 6 minus 1 minus of 2, 4 minus 3 plus 3, 2 minus of 9 into A, right? So this becomes 5 minus 2, which is 3, then minus 21. So this becomes minus of 18. So minus of 18 into A. Okay. So checking with this. So second is the correct answer. Second is the correct answer. So with these properties, we have finished the chapter here. Okay, so only example part is left out. Okay, so first example we've seen. Now let's move to the second one. So in the second one, matrix 2 into 2 matrix is given, which is PQ and minus QP, right? And one more matrix is given, which is also 2 into 2 matrix, which is RS and minus S and R. Okay, so you need to find whether AB is equals to BA or AB is not equals to BA or AB is equals to minus of BA or none of this, right? So here for the AB, we'll write it as PR minus QS, PS plus QR, minus QR minus PS, minus QS plus PR, right? Now let's find the BA. So RP minus QS, QR plus SP, minus SP minus QR, and then minus QS plus PR. So from both AB and BA, we can clearly say AB is equals to BA. So option 1 is the correct answer. Option 1 is the correct answer. Option 1 is the correct option. Next problem. If a function in the terms of alpha is given, which is cos alpha, sin alpha, minus of sin alpha, and the cos alpha, and if alpha, beta, gamma are the angle of triangle, okay, then we need to find f of alpha into f of beta into f of gamma equals, okay. So here f of alpha into f of beta, which is or cos alpha, sin alpha, minus sin alpha, cos alpha. Similarly for beta, cos beta, sin beta, minus sin beta, cos beta, right? Now here you can multiply, so you'll get cos alpha, cos beta, minus sin alpha, sin beta. Then cos alpha sin beta plus sin alpha cos beta. Again, minus of sin alpha cos beta minus of cos alpha sin beta. And the last is this minus sin alpha sin beta plus cos alpha cos beta. So solving, you will get it as cos alpha plus beta sin alpha plus beta minus of sin alpha plus beta cos alpha plus beta. Similarly, you will match with the alpha, beta, and the gamma, right? So you'll get it as cos alpha plus beta plus gamma, sine alpha plus beta plus gamma, minus of sine alpha plus beta plus gamma, and the cos alpha beta gamma. All these in the addition. So here it becomes cos pi sine pi minus of sine pi and the cos pi, which is equals alpha plus beta plus gamma is equals to pi, right? So you can write it as minus 1, 0, minus 1, 0, then 0, then minus 1, right? So minus 1 take out common. So 1, 0, 0, 1. So which is minus of I2, right? So here option number second is the correct answer. So this one was a good problem. Okay. So can copy it on this. Now copy it on this one also. Okay. Next example, function in the terms of m alpha is given, okay, which is your cos alpha minus of sin alpha, then 0, then sin alpha cos alpha, then 0, then 0, 0, 1. Similarly, m beta is given the same cos beta 0 sin beta 0, 1, 0 minus sin beta 0 cos beta. Need to find the m of alpha, then m of beta, and whole inverse, which is equals, right? So you can write it as m beta m alpha m beta whole inverse, which you can write it as m beta inverse m alpha inverse, right? So first need to find the m alpha inverse, so which becomes cos of minus alpha minus sine minus alpha 0. Then here sine of minus alpha cos of minus alpha, then 0, then 0, 0, 1, which is your m minus of alpha, right? Similarly, you'll find the m beta inverse. So which becomes cos minus beta 0, sine minus beta 0, 1, 0, minus sine minus beta, then 0, cos minus of beta, right? So which is m minus of beta. So here you can write it as m alpha m beta, which is whole inverse. So m minus of beta minus of alpha. So meaning option third is the correct answer. Just solve all the question by properties only. Okay. Next, if I is 1001 and j is 01 minus 10, and b is given cos theta sin theta minus sin theta cos theta, then b is equals. Okay. So here cos theta sin theta minus sin theta cos theta, which is equals to cos theta 0 0 cos theta plus 0 sin theta minus sin theta 0. So which will become cos theta 1001 plus sin theta 01 minus 10. So which becomes I cos theta plus j sin theta, means option 1, I cos theta plus j sin theta. Next, example number 6. Uh, a matrix 2 into 2 given, A and B, two matrices are given. So first is cos square theta, cos theta sin theta, then cos theta sin theta, then sin square theta. Second is cos phi sin phi, cos phi sin phi, and then sin square phi. And here given AB is equals 0, and then we need to find theta minus phi is equals to. Okay. So here first AB. So check AB for all these given conditions. So you will get it as 0 0 0 0. So if phi cos theta minus phi is equals to 0, then theta minus phi is an odd multiple of pi by 2, right? If cos theta minus phi is equals to 0, then theta minus phi is an odd multiple of pi by 2. So means option 3 is the correct answer. Next is if k given, which is minus 1 2 2, then 2 minus 1 2, then 2 2 minus 1, which is an orthogonal matrix. Okay, then we need to find the k is equals to what, right? So here let k is a minus 1 2 2 2 minus 1 2 2 2 minus 1. So let's find out the transpose for this. So k will become minus 1 2 2 2 minus 1 2 2 2 minus 1 into k, right? So is orthogonal. So a into a transpose is always equals to I. Okay. So here first we'll move for the k square. So same you will get similarly k square into this given values. So which become k square 900 090 and 009. So which becomes 9k square into I. So k square is equals to 9. So k square equals to 1 by 9. So k will become plus minus 1 by 3. Plus minus 1 by 3, meaning option 3 is the correct option. Okay, so this is related to the orthogonal matrix, which is special case, first number special case, which we are seeing today, right? Okay, next problem. if a is 1011, then we need to find a to the power minus 1, which is equals to what? Okay, so given a 1011, so let's find out the a inverse a to the power minus 1. So 1 by 1, 10 minus 1 1, so 10 minus 1 1, so a minus 2 will become 1 minus 101 1 minus 101, so which becomes 10 minus 2 1, right? 10 minus 2 1. So for a it will become a to the power minus n, so 10 minus n and 1, right? So meaning option 3, 10 minus n and 1. So this one is the correct. This third option is the correct, 10 minus 1 and 1. Okay, one more problem, ninth one. If matrix is 3 into 3 matrix is given, you need to find the adjoint a is equals to what? Okay, so just check out this. Okay, for adjoint aij, we'll compare all the values. Okay, 0 4 6 7, all the corresponding values, so you will get it as minus 24 minus 730 4 1 minus 2 8 11 minus 10. So transpose of aij will get adjoint a, so this will as, let's change the row into column, so minus 24 minus 27 30 4 1 minus 2 and 8 11 minus 10. So in the option, so third is the correct answer. Third one is the correct answer, right? Now next is, if a is given 4 1 2 3, then modulus of a is equals to what? Okay, so when you solve 4 into 3 minus 1 into 2, so this will, you will get it is 10. Okay, so option 3 is the correct answer. This one was a very easy problem. Okay, a11 a12 a21 a22, so just a11 a22 minus a12 a21. Okay, so this was tracing matrix. Okay, tracing of matrix, and we will get your value as 10. Next is which statement is true? A is 2 minus 1 minus 7 4, and B is 4 1 7 2. Okay, so A of A transpose, you need to find which is not equals to 1001. So B of B transpose 11. So 4 square plus 1 square is not equals to 1, right? This will become 17. And AB 11 8 minus 7 1, and BA 11 8 minus 7, which is equals to 1. So AB is equals to B, not equals to BA may not be true. Okay, so now go for the values. So 2 minus 1 minus 7 4, and 4 1 7 2. So 8 minus 7 and 2 minus 2, and minus 28 plus 28 minus 7 8 minus 7 plus 8. So 1001. So AB whole transpose 1001. So that is your I. So meaning option fourth is the correct option. Okay. So here with this I will wind up the session here. Okay. So we'll check out more questions in the next lecture.